So, why AI? I mean, really, why did we even need to invent something so complex? Weren't our computers already super powerful? Today, we're going to unpack the huge shift in thinking that made AI not just some cool idea, but an absolute necessity. And it all kicks off with a surprisingly tricky question. All right, let's start with this. Is 34.9 degrees Celsius cool? For us, the answer is, well, it's complicated, right? It depends. But for a traditional computer, this kind of question is a total nightmare. And understanding why it's a nightmare is the key to unlocking why AI was ever invented in the first place. To really get it, we need to kind of rewind the clock. We need to step back into the world before AI. This was a world built on the powerful, elegant foundation of fixed rules, the world of what we call deterministic computing. At its core, deterministic computing is all about one thing: certainty. You put something in, you get a specific thing out. And if you put that same input in a million times, you will get the exact same output, every single time. No exceptions. This predictability is the rock-solid bedrock of most software we've relied on for decades. So how does it pull off this perfect predictability? Well, it's built on two brilliantly simple ideas. First, everything, and I mean everything, gets boiled down to just zeros and ones. That's the binary logic system. Second, all that data flows through these things called conditional gates. You can think of them like microscopic traffic cops, enforcing super strict if-then rules. There is absolutely no maybe allowed. And you know what? For a certain kind of problem, this system is perfect. It's an absolute dream for problems that have one and only one correct answer. Just think about it, right? Calculating the interest on your loan or solving a massive math equation. You definitely don't want your banking app to give you its best guess on your balance, do you? No way! You need the single correct number. And for that kind of job, deterministic computing is still the king, the perfect, most efficient tool. But here's the twist. What happens when you take this perfect, logical system and you throw our messy, unpredictable human world at it? Well, that's when you start to see the cracks appear in the code. Because let's be real, our world isn't a neat little math equation. It's filled with uncertainty, with subjectivity. Is this a picture of a cat? Is this email just spam? Should I recommend this movie to you? I mean, these aren't simple yes or no questions, are they? They're all about probability. They're about likelihood. And suddenly, there's this huge gap, this chasm between what our perfectly logical computers could do and what we actually needed them to do. This wasn't some minor bug. It was a fundamental roadblock. And to get past it, we needed a whole new way of thinking. And this, right here, is where AI enters the story. Instead of trying to cram our messy reality into rigid little boxes, a completely new approach emerged. One that didn't just tolerate uncertainty, it embraced it. This is the probabilistic paradigm. And this slide, this really nails the huge philosophical leap. On one side, you've got classical computing, always hunting for the single correct answer based on ironclad rules. On the other, you have AI, operating on probability, trying to find the best possible prediction. It's a massive shift from demanding absolute certainty to making intelligent, calculated estimations. Exactly. So instead of following a strict flowchart, an AI looks at all the data and says, based on everything I've seen, there's about a 95% chance this is a cat. Or, there's an 80% chance this email is spam. It's finally thinking in shades of gray, not just in black and white. But hold on, this doesn't mean we just throw out the old rulebook. Not at all. The rise of AI isn't about replacement. It's about adding an incredibly powerful new tool to the toolbox. And crucially, knowing when to use it. This brings us to a really important idea: the AI discretion. Look, if a problem has a fixed, known outcome, using a giant AI for it is, well, it's like using a sledgehammer to crack a nut. It's total overkill. For those straightforward, deterministic jobs, good old-fashioned programming is still way faster and more efficient. Okay, so let's circle all the way back to our temperature question and see how these two different worlds handle it. A deterministic machine sees things in what we call discrete distinctions. It's either one thing or it's the other. But we humans, we think on a spectrum, a continuous range. So here's that classic computer logic. You program a rule. If the temperature is greater than 35 degrees, it's hot. Simple enough. Well, by that logic, 34.9 degrees is, by definition, not hot or cool. There's no wiggle room. It's perfectly logical. but it feels completely wrong, doesn't it? But a human, and now an AI, gets the nuance. We can describe that temperature with all sorts of words: cool, pleasant, warm, hot. It's a spectrum. And by learning from just massive amounts of data, AI can finally start to understand this context, interpreting the world in a much more human-like way. And that really brings our journey full circle. We started with the beautiful certainty of deterministic computers built on binary logic, but the messiness of the real world created a gap those systems just couldn't cross, which led directly to the invention of AI and its power to navigate a probabilistic world. So if you remember one thing, let it be this. AI was invented because rigid rules just weren't cutting it anymore. We needed to build machines that could handle the subjectivity, the nuance, and the infinite shades of gray that make up our actual experience of the world. Which leaves us with a really fascinating thought to chew on. For decades, uncertainty was this huge, impossible wall for computers. Now that they're getting better and better at climbing over it, what's the next truly impossible human problem they might actually help us solve?